Hello, everybody. Thanks for coming out tonight. My name is Scott Allison. I'm the Senior Technical Product Manager for AWS Greengrass. And this is session IOT365, introducing the new features of AWS IoT Greengrass. And thanks for coming out. So we're going to be talking a lot about release 1.7 of Greengrass tonight. You guys may have seen it released on Monday. There are a lot of new features to cover, a lot of things that we think you can make good use of. And we're really looking forward to talking about them. So let's start with a little bit of an introduction about AWS IoT Greengrass. When we talk about IoT deployments, we usually talk about it in terms of the three laws. We talk about the laws of physics, the laws of economics, and the laws of the land. So in each case, the law of physics, the speed of light only goes so fast, so you probably want to be able to operate on your data locally, perform actions, cache things so that you can do things at the edge. The law of economics, it can be expensive to transit a lot of data to the cloud, and so you may want to filter or analyze the data at the edge to minimize the amount of data you send off out of the edge into the cloud. And then in terms of the law of the land, there may be regulations like HIPAA or GDPR that require you to perform operations on premises. So in order to make that possible, we built AWS IoT Greengrass. And we added some features that we think help with all of these things. So we built a platform for local code execution using Lambda that allow you to perform actions at the edge with a familiar format that you already know in AWS Lambda. Secure connectivity allows you to communicate securely with the devices on premises, services in the cloud, and other Greengrass devices. ML inference, so that you can move ML models to the edge and perform analysis and ML at the edge without having to work in the cloud. And local actions and resources, allowing you to access cameras and the file system and other pieces of hardware to perform actions using the devices at the edge. So what does that look like in practice, right? Now, you guys are probably already pretty familiar with how it works computing at the edge because you already use AWS IoT Greengrass. But a common edge scenario might be you're collecting some data from on-premises devices like thermometers, temperature sensors, industrial devices, cars. You're caching and analyzing that data on the Greengrass core, filtering it, doing some sort of work on it, and then performing local actions or transferring the data to cloud services like CloudWatch or SNS. So at each step along the way, you're building things in Lambda or you're building things that require authentication to other services. So what we've tried to do with release 1.7 is to make it easier to build and deploy applications to the edge using AWS IoT Greengrass Connectors. And we have Dimitri Zmin from Extreme Networks to give a demo of what that might look like. And then we have enhanced security features to help you secure the applications that you build in AWS IoT Greengrass. So we've got AWS IoT Greengrass Secrets Manager, which is an extension of the AWS Secrets Manager to the edge. And then AWS IoT Greengrass Hardware Security Integration, which is hardware security integration. And then we have Logic Supply here to give a demo of that. And then greater flexibility. So we allow Greengrass per Lambda isolation and permission configurations now in 1.7. Those are the things that we'll be covering in this session, but there are a lot of other pieces to this release that are also important that you might be interested in. We have the ability to perform bulk deployments now to multiple AWS Greengrass groups. And then we also have support for ALPN and proxy if you have network scenarios that require you to work in a restricted network environment. And we've improved ML inference in 1.7. We made it more performant with a smaller footprint. There's a lot to talk about there, and so we have a separate session for that. That's IoT214, Machine Learning at the IoT Edge, and that's tomorrow at 11:30 at the Venetian. So let's talk a little bit about the simplified deployments piece of 1.7. AWS IoT Greengrass Connectors, which I just mentioned. What are they? So we know that when people build applications using AWS IoT Greengrass, they tend to do a lot of things over and over again, and they write Lambdas to do that, processing the data, moving it to cloud services, connecting to devices that use industrial protocols, and connecting to AWS services. So what we wanted to do was make it easier for you to do that without having to write code. So what AWS Greengrass Connectors are prepackaged bundles of Lambda functions and MQTT topics and secrets that allow you to perform those actions and configure them simply from the console just by filling out some parameters. So there are 11 of them available today, 8 familiar things that you might be using at the edge already, plus 3 integrations with third-party services, CloudWatch events, or CloudWatch metrics, AWS IoT Device Defender, SNS, And if you're using a third-party service, Twilio, Splunk, or ServiceNow. We're not done creating and releasing connectors, and we're working with several partners in 2019. We'll be working with Intel and their OpenVINO SDK to create a connector that allows you to connect with that easily, with NVIDIA for their DeepStream SDK, and OSI Soft for industrial historian use cases with their Pi offering. And in addition to that, we're going to allow you to edit the connectors that we already provide to you and build your own connectors. And that's coming as well. We know that the contribution mechanism is best from you guys, the customers, and so we want to enable that as well. So what does an AWS IoT Greengrass connector do, and how does it work? Well, it's easy enough to find. You go into the AWS Greengrass console, open it up, and then you'll see connectors as a new section. Within that section, there's a list of all the available connectors. You can select them from the list and attach them to a Greengrass group and then deploy them. So a good example of that is the SNS connector. Whereas previously you might have written a Lambda function to connect, authenticate, and pass data to Amazon SNS, the connector does that for you. It's a straightforward configuration. You go into SNS, create an SNS topic, save that ARN, come back to Greengrass, add the AWS Greengrass connector for SNS to your group, and configure it. And the configuration of this is just adding the ARN of the SNS topic to that and hitting finish, and then you attach and deploy. And once it's deployed, there'll be an MQTT topic out there with the name. All you have to do is publish to that topic, and anything published to that topic will be sent to the SNS topic you desired. And if you don't use SNS, say for example you're using Twilio, we also have a connector for that, and the configuration is very much the same. So you'd add your auth token for Twilio to AWS Secrets Manager using AWS Greengrass Secrets Manager, which I'll talk about a little bit later. And then you'd specify the phone number and SID, deploy, and then it would also create an MQTT topic you would publish to, and those messages would be sent via Twilio. So that's the theory of how Greengrass connectors work. For a practical example, I'd like to invite Dimitri Zamin from Extreme Networks to the stage to give a little demo and talk about what he's done with it.
Here to show you something that we did with Greengrass and Greengrass connectors. But first, a few words about Extreme. Extreme Networks, we build networks, hardware and software network solutions for wired and wireless, edge, campus, data center, the whole range. If you didn't hear much about Extreme, that's okay, it's changing. We are accelerated to become #3 network company in data center, and this year we are in the leaders quadrant of the Gartner Magic Quadrant for wireless and wired. When it comes to IoT, networking is always part of the picture, but at Extreme we don't bring just the networking pipes. There are interesting devices with interesting form factors, like specialized device, outdoor switches, the access points with video cameras on them, the small form factor devices like a Volt plate. These devices have hardware support for IoT protocols, Bluetooth Low Energy, Thread, others. We have Wi-Fi based and Bluetooth based location services on that. That makes Extreme part of the multiple IoT solutions for many verticals. Here is a neat example. This is a smart device. This is how it looks, which is part of the software hardware solution for the IoT in the healthcare. It effectively builds a simple security for intrinsically unsecure devices by creating the tunnels and applying the policies to the devices. Now you think, okay, Extreme is cool, but what does it all have to do with the IoT? With Greengrass specifically and with AWS services? Well, here's the deal. We build a variety of the next generation hardware, switches, access points, controllers. These things have huge excess compute capacity. And we want to turn this capacity to run Greengrass right on these devices and give it to you to run your network. Yes, you will be able to run your Greengrass workloads right on the network. And this is good because you don't need to introduce another IoT domain. You can use something that's already in place. It is already managed. It's already secured. It's already monitored. It's paid for. And while with that, you can tap into the information that comes from the extreme devices, IoT information, network information, location information. We put that to test with our partners, Schneider Electric, their industrial innovation team. They want to take the data from a vast array of industrial devices that speak industrial protocols like Modbus and OPT-UA, but do not talk to AWS over MQTT. And they want to push this data to the cloud. Once in the cloud, they want to run analytics to get insights and provide the unified view to all the devices. Finally, they want to close the control loop so that the actions run as close to device as possible. While doing that, they want to maximize the security and minimize the cost, which effectively rules out introducing a new IT domain. Their extreme networks with Greengrass running right on the network devices fit squarely. So here is the POC. There is a motor with a load on that, controlled by the variable speed drive. This is a very smart thing that, among other cool things, knows to talk TCP over kind of Modbus over TCP. We take this device and connected that, literally unplugged that from the variable speed control and plug it here and plug the other part to the cloud. How close to the cloud it can be? If you want it closer, just cut the network cable. Like the Greengrass, already pre-configured and pre-installed on the image. So once you plug it in, it can be deployed. When deployed, there are two Lambda functions running there. One pulls the device for the data and sends them to the cloud. Another runs anomaly detection right there. And we also used the new Modbus connector from AWS to do the ad hoc request to the devices, as well as controlling the device. When the message hits the cloud, it goes to the IoT rule, and then we send that to the IoT analytics for cranking the data later. And we send that to Elasticsearch and Kibana for providing the live dashboards. OK, let's get into the code. I use GreenGo, the utility that lets me define the full group definition as YAML, and then push that and create that into AWS Cloud. Well, we all believe in infrastructure as code, right? So I can do that repeatedly, or I can put it in GitHub and share that with you, which I'm going to do right after this session, so don't run away. So here we have the first Lambda definition, the Modbus data collector protocol that pulls data. Then second Lambda definition, anomaly detection. The code will be on GitHub. You can see the algorithms and everything of how to use that. Scrolling down, here is the new AWS Greengrass connector, the Modbus connector. As you can see, I referred that by the ARN. It takes some parameters. And finally, subscriptions. Who is talking to whom or which topics? So here, the Modbus Lambda reads the devices, publish them to the cloud, as well as to the anomaly catcher Lambda. When anomaly catches, it gets published to the cloud. And the Modbus connector talks to the cloud for request and response. OK. Finally, the rule. When anomaly happens, we form the request to the Modbus connector that stops the motor by setting the speed, the frequency to 0, and post that to the Modbus connector over HTTP topic. We could have done that with Lambda. Probably in production, it would be better to do so. But for prototype, it's easy to turn on and off the rule, so it looks better. OK. Getting closer. I wish I brought the device, but it is pretty big and very loud, so I don't have the device with me. But the dashboard will tell the story. Here is the dashboard. And we have the previous run here, and the motor right now is stopped. So I go and start the motor by setting the speed to 150, publish that to MQTT topic. The Modbus connector picks it up. We go back to the dashboard. So you can see the torque right now jumps up. There are a couple of anomalies catched because the torque jumps up and down. Here I'm changing the resolution for the better view. The graph shows the torque. The graph on the top shows the anomalies along with the data. A few other interesting things. I fast forward that. So now we're going to inflict an anomaly. We want to grab the motor for the shaft so that the speed goes down and the current and the torque goes up. So hold it up, grab. OK, we see if it jumps up. But the rule is not yet enabled. So nothing is happening. The anomaly is registered. The anomaly is posted, overlaid, all cool, data in the cloud. But we keep on going. So the motor keeps on running. I'm keep on waiting. I probably will fast forward that again. About now. How's it going? Boring. And now I go and enable the rule. So go there, actions, enable the rule. I hate this UI with a passion. I almost killed the rule by clicking delete because it's next to enable. So rule now is enabled. We come back. It caught some anomaly. But this anomaly was caught before the rule is enabled. In fact, it's a funny story. The guy was sitting on a chair, and it ran the chair close to the device. The rod hit the chair, and we caught the anomaly before on this one, before we actually saw that, like what's going on. So now we actually grab that by the shaft, and I will hold that by the shaft for as long as I can so the motor will burn. And I'm holding this, and the motor shuts down. We just save the motor. That's it. You can see extreme devices which are currently Greengrass capable in the device catalog already. And as I promised, everything that you've seen here is already on GitHub. I'll keep the slide on so that you take your pictures. And for questions, comments, feedback, or drinks, I'll stick around.
That's great. Thanks, Dimitri. All right, now that you've seen a demo of connectors in action, let's move on and talk a little bit about the enhanced security features of the 1.7 release. So, as we mentioned before, we're extending AWS Secrets Manager to the edge with AWS IoT Greengrass Secrets Manager. Now, some of you may be familiar with AWS Secrets Manager already. You may be using it. If you're not, it's a cloud service for storing things like keys, passwords, credentials, and configurations in an encrypted space. So what we've done is we've extended Greengrass such that secrets are now available as resources that can be attached to and deployed to Greengrass groups. So it's easy enough to use, and they're usable by connectors and Lambda functions. But how does that really work? It works very similarly to any other resource you would attach in Greengrass today. So you go into Secrets Manager, provision your secrets there, and then go right back to the Greengrass console. And from the Greengrass console, underneath the Resource tab, you'll now see a new type of resource called Secret. You can select any secret that you stored in AWS Secrets Manager, any version of that, and they're encrypted in transit and at rest on the device and in transit from the cloud. So it's pretty straightforward, it's easy to use, and we hope it'll help you secure your applications at the edge without having to hard code passwords or manage the storage of those secrets yourselves on the devices. But that's not all we have to talk about in terms of security. So I'd like to invite Tatiana Cook to the stage so she can take over and talk about more security features.
Great, thanks. My name's Tatiana Cook. I'm another product manager on the Greengrass team. So I've been working closely with Scott and the rest of our team to bring you guys some new exciting security capabilities. You've heard a little bit from Dimitri about applications that you can build and deploy to your edge devices and this new capability to bring secrets to the edge. But I'm sure securing these new capabilities is top of mind for you. So first, I'll break down a little bit about our existing security architecture, and then I can tell you about a new hardware security feature that we have that will help you ensure that anything you bring to the edge stays secure. With Greengrass today, we help protect messages that you're sending between the Greengrass core on your local device and the IoT cloud, and between your Greengrass core and other local devices, maybe the truck shown in this picture, by using a few different capabilities. First of all, we ensure that your identity is correct for the device when it connects to the cloud by using IAM roles. So that means that when you connect from your Greengrass core to the cloud, you only have access to the right resources that you've provisioned for your device to access. Second of all, we use TLS encryption of all of the messages sent between the Greengrass core and the cloud and the Greengrass core and your local device. And we use a variety of different cipher suites as options to do that. As part of that TLS encryption, we provide a private and public key that are stored on the Greengrass device that are helped to use to encrypt and decrypt these messages, along with the X509 certificates that you use for that messaging connection when you establish it. Right now, Greengrass allows you to store a private key in the file system on your device so that you can use that private key to decrypt any messages sent to you with the corresponding public key. Today, we're excited to announce a new capability because what we've heard from many customers is that they might be interested in running devices that are in unsecure physical locations. For example, they might want to put a transponder on a vehicle that's moving around in the real world so they can flag when it moves out of the zone they've allowed it to be navigating through. You might want to be measuring HVAC sensors within a hospital, and you could have a gateway device in that hospital that may not be physically secured, so maybe the maintenance staff can physically get access to that device. Or you could be interested in using video cameras at a conference with more than 50,000 people to capture images that allow you to make sure that buses are in the right place at the right time. And this is a real use case that our protective services team reached out to us about. So many of you at this point in the conference have probably tried to get from one place to another, and you might have taken advantage of the wait time information that's provided to you in your AWS app. And there are three pieces to that. So there's walking information, there's information about how long it would take to get Uber or Lyft, and there's shuttle time information. This information isn't publicly available. It's something that is being generated by our teams. And we worked with the protective services team to help enable the architecture getting that information. So the way that this works is you're waiting in line. Maybe you were trying to get to hear from the Venetian. And as you may have noticed, you were shepherded over certain arrows. Some of you may have been yelled at for not walking over the right carpeted portion when you were trying to get in line. And that's because we have video cameras, 44 different cameras, that are pointing at those lines, counting people as they go in and out. One of the things that we did as part of this was actually run processing on the camera devices themselves so that we're not saving pictures of the back of your head in the cloud so that we can go back and look at them later. The video cameras actually do processing, and they count in and out information. That information, so that flow and line data, not the video or image information from the cameras, was sent to logic supply devices, and James will talk a little bit more about the logic supply device and their implementation of Intel's TPM 2.0. But those logic supply gateway devices are running AWS Greengrass. And what Greengrass is able to do is securely send information from that device up to the cloud, where applications are running to help calculate how many people are in line and notify both you of how long the wait is and the bus company that's sending new buses to help get those line times down. Part of the reason Protective Services reached out to us is because they had this logic supply hardware with the Intel Trusted Platform module, but they weren't able to integrate it with their edge application. And what we're excited to announce with Greengrass is hardware security integration that allows you to use the public key that's securely generated and stored on a trusted platform module or other kind of edge secure element. And that means that it's in a tamper-proof location. The private key never leaves the location itself, so that the messages you're sending from the core to the cloud or the core to local devices stay encrypted and can't be decrypted by a rogue agent. So the big change here is that you'll have the opportunity to integrate through a PKCS11 interface with a hardware secure element. Maybe you have hardware secure elements present on the devices you're using today, and this is really great because all you'll need to do is deploy new firmware from your secure element provider and update your Greengrass core to run version 1.7. It's easy to get started with this. So first of all, you'll follow your vendor's directions to generate a private key on your secure element. The next thing you'll do is you'll update your Greengrass config.json file to point towards the secure element rather than the file system private key path that you might have in the past. You'll also want to make sure that you authenticate the certificates you're using correctly to take advantage of that private key. The last piece of this is integration with the AWS IoT secrets that Scott mentioned. Through Greengrass Secrets Manager, you can bring those to the edge. And if you have a secure element on your device, you can use that for encryption and decryption of those secrets to make sure that the private information you're using for your applications stays secure. We're really thrilled to be able to announce this with a variety of different partners we worked with. So a lot of thanks to the teams at Intel, Logic Supply, Microchip, Infineon, NXP, ST Microelectronics, Soracom, Vitro, Yubico, and Zimbit. They're all partners who are qualifying their hardware to work with this security integration. If you're interested in getting started today or learning more about devices that have gone through the qualification process, you can get that information through our new partner device catalog by searching for HSI. You can see some of the devices that are directly available for purchase now, and because of the variety of vendors we worked with, we think that there are a lot of different things to meet the needs that you might have at the edge. If you're a partner in the audience and you hear this and you say, how can I get on these slides? We have a new device tester program that's allowing our partners to have tooling and become qualified for things like hardware security integration. So that's publicly available now as well. You've heard me talk for a little bit about the theory of how to do this, and I'm now excited to welcome James Floyd from the Logic Supply team up to the stage to talk about the work that his team has done for hardware security integration.
Thank you, Tatiana. Thanks, everyone, for being here tonight. My name is James Floyd. I'm a sales engineer at Logic Supply. And I work very closely with our sales team and our customers to understand their needs and making sure we're putting the right solution in front of them. Tonight, I'm happy to talk to you about hardware security integration within the Greengrass core. But first, who is Logic Supply? Logic Supply is an industrial computer manufacturer. We are located in Vermont. Also located in Vermont is maple syrup, as I'm sure you guys are all aware of. Some of the best beer, if anyone's ever had Heady Topper, and also ice cream, Ben & Jerry's. Our focus at Logic Supply is on small form factor hardware and industrial designs. Our computer systems are used by software companies that need a hardware element to make their solution whole. They also use our OEM services like branding, imaging, and direct fulfillment services. And we also work with many end users who use our systems as workstations and thin clients in factory environments. Those customers like our reliable designs and embedded life cycles. We've been working with the Greengrass group since the beginning of the year to certify our hardware platforms with the Greengrass core. We're excited today to be able to now leverage hardware security within the Greengrass core. Working with the AWS group and Intel, we're leveraging Intel's platform trust technology to make this happen. With a secure element in place, we're able to address a lot of our concerns as it relates to security, specifically at the cloud. A use case that we like to highlight is a typical heating, ventilation, air conditioning, HVAC. How many of you have a Nest at home? I love my Nest. It allows me to optimize cooling within my house and lower my energy costs. At a much larger scale, like within a hospital, there are a lot of more risks involved with bringing a system like that online. Some of those risks include spoofing or rogue devices, man-in-the-middle attacks, and denial of service. Next, I want to show you real quick how easy it is to actually implement hardware security within the Greengrass core. There's a short video that I'll walk you through. First, we're generating a set of keys for a new AWS Greengrass group. Next, we're downloading the private key that is used to connect the Greengrass group and moving it to a location where it can be found by a TPM script. Here we're looking at the TPM script's location, highlighting the various items that will be used in the config file, along with expected location of the private key. Next, we run the script so that the private key's hash will be integrated into the system via Intel PTT. Next, we move over the Greengrass folder to view the config files. And lastly, we log into and run Greengrass with the secure element now in place. Success. Cool. Now with a hardware secure element in place, we're able to address some of the concerns we mentioned before, specifically for rogue devices and spoofing. The hardware secure element is now physically located within the PTT and TPM within the device itself. If anyone ever gets physically located by your device, they will not have access to the secure element because it's no longer the file system. It's physically on the device. We're also addressing the man-in-the-middle concerns and communications encrypted using the transport layer security protocol. And lastly, the denial of service. The only registered devices can access the file system. With hardware security integration in place, we've moved from a solution where the private and public keys were stored within the file system and had the potential of being compromised. Now we have a physical secure element in place where people will not have access to the keys from the file system. We're able to leverage that using AWS and their hardware secure integration, Intel's trusted platform technology, all on Logic Supply's intelligent gateway. Thank you.
There's more. Great, thanks, James. We'll now dive in to the third set of capabilities that we're excited to be able to announce today. So we've heard from customers since Greengrass launched that customers want to use Greengrass in a diverse set of environments. They might be interested in running AWS IoT Greengrass inside of a Docker container. They could want to run Greengrass on a device where there are fewer dependencies and they don't have to make kernel-level changes. Finally, customers are interested in accessing more local resources like Bluetooth Low Energy or USB devices that don't have a fixed file path. We're making it easier for customers to get up and running with Greengrass, regardless of what environment they're interested in running Greengrass in. So today, with this new capability that I'm about to describe, you'll be able to run AWS IoT Greengrass in a Docker container. This is possible because we're giving you more flexibility. So to start off with, today, Greengrass provides per Lambda container isolation. So when you're running applications on the edge with Greengrass, you get the benefits of isolation and security that come with having a container environment provided for you. And this is part of our current model. It's something that by default will still be present when you configure a Greengrass group in the cloud and deploy all of your Lambdas to the edge. We have something called local resource access that allows you to interact with device resources locally through that container environment. We think customers enjoy the fact that this brings a lot of security benefits with it, and you have the benefit of your Lambdas all being isolated from each other. However, in some cases, you might want to let loose a little bit and allow those Lambdas to run as OS processes. We have a new mode that we're introducing where Lambdas in Greengrass have no container present. This means that it's easier to directly access the operating system or hardware environment that you've deployed Greengrass to, or interact directly with device resources. Finally, customers will have the option to run a hybrid mix, where they deploy containerization for some of their Lambdas, but they want to configure certain Lambdas. For example, if you have an application that you want to interact with a BLE device, you can configure that to run without a container present. This means that you still get the security and isolation benefits where you need them, but you can toggle that containerization off on a per Lambda basis and be really granular about the way that you configure device access. This is going to be, or it is now live today, and it's easy for you to configure this from the console or a CLI. So you can select at a group level whether or not you want a container, and you can also go in and edit per Lambda container isolation settings. We're also giving you more granularity in the way that you allow permissions for different Lambdas. So previously, all Lambdas ran with the same group and user ID, GGC user and GGC group. Now, you'll have the ability on a per Lambda basis to edit whether or not that Lambda is associated with that user ID and group or a new user ID and group. For example, if you want to restrict permissions for a particular application or to allow certain applications to run as root, you'll have the ability to have that really close control over permissions. This is really exciting for a lot of the developers out there because the Docker capability means that you can run Greengrass in Docker on Mac OS 10 or on Windows 10. So we think it'll be really easy for you to get started running Greengrass in those environments if you don't want to try them on your edge device. I know there's a lot that we talked through, so I'll kind of do a quick wrap up and tell you how to get started with all of these exciting new features that our team's been working on. As Scott mentioned, for simplified deployments, if you want to try out the 11 Greengrass connectors we have available today, documentation for those connectors is all available through the console. So you can go check that out. And as he mentioned, we'll have new connectors coming live in 2019. For enhanced security, you can configure your secrets and attach them to resources in the console, and you can find qualified hardware to take advantage of hardware root of trust for your security architecture. We encourage you to search the Amazon Partner Device Network for any Greengrass HSI qualified devices. Finally, we're really excited that alongside this greater flexibility, we're also providing customers access to Greengrass that is packaged up as a Docker image for you to deploy to whatever edge device you'd like to run it in if you want to run Greengrass inside of a Docker container. So there are links here, and you can find documentation for how to access our Docker file and Docker image online through the console. Thank you all for your attention, and Scott and I are now happy to answer any questions you have about the capabilities in Release 1.7.
Question? Yeah.
You mentioned that there was a support for proxies. Would that allow now that if you have a network setup where you are restricted from connecting the Greengrass device directly to the internet, so that you need to have an intermediate layer communicating with IoT core?
Yes, yeah, that's correct. So within the config JSON for the Greengrass core, you can now specify the address of the proxy and the port you'll be communicating on. Yes. Other questions?
Yeah. We did such a good job explaining everything.
All right, we did it. Awesome. Well, thanks for coming, guys. We really appreciate you being here. Enjoy Las Vegas.